Hello, dear students. In this subject, groundwater assessment and development. Okay. Today, I'll continue that chapter, groundwater hydrology. Already in this chapter, we have discussed importance of groundwater, available water on Earth, and we discussed in the last class the groundwater quality status of India, and we discussed groundwater board, central groundwater board, from where you can collect data, where you can collect any information in it. Okay, so today I'll teach about hydrologic cycle, the processes involved in the hydrologic cycle. Okay, and the water budget that we discussed in today's class. Hydrologic cycle that we know that it consists of evaporation, okay, then condensation, then there will be precipitation, okay, then runoff, infiltration. Okay, these are the processes, main processes involved in the hydrological cycle. This evaporation can be from ocean, from lakes, from any water body, from vegetation, from land. If it is from vegetation, it is combined with the transpiration. Transpiration, it is called evapotranspiration. Okay, so evaporation, after evaporation, there will be condensation. Okay, and the condensation, there will be rainfall. And rainfall means precipitation. It can be rainfall, it can be snowfall. After that, there will be surface runoff, the water that flows on the surface, that is the surface runoff, and some part of the rainfall infiltrate into the ground. That is called infiltration. That is called subsurface flow, or it is called groundwater flow. Some part of the water joined to the groundwater, some part travels in the upper layer of the soil and it joins the water body, either in ocean or lake or river. Okay, some upper part it joins later. So these are the process of hydrology cycle. It is a cyclic process. And this is another figure, this is a 3D figure of this hydrologic cycle. There will be evaporation from vegetation, from streams, from soil, from ocean, and there will be transpiration from this vegetation, and there will be cloud formation, and there will be precipitation. And the precipitation water, there will be runoff. Okay, there will be runoff and infiltration. Infiltration and percolation. Infiltration means infiltration means it fills the porosity of the soil. Okay, and percolation means it is after filling of this porosity of the soil, means when soil is fully saturated, when again water enters into the ground, that water joins to the water table, groundwater table. That is called percolation. Okay, so infiltration you can say in two types, that is absorption and percolation. Absorption means the pores of the soil is filled with water. Percolation means after filling of water, the soil, when soil is fully saturated, the water flows to the groundwater table. Okay, that is called percolation. This is another hydrologic cycle picture. Here there will be evaporation. Okay, both from lakes, from ocean. Okay, and from vegetation there will be evapotranspiration. Okay, there will be cloud formation after evaporation, and there will be precipitation. Okay, and infiltration. Okay, and some part of the infiltrated water joined to the stream later. Some part flows in the upper part or layer, and it may join to the ocean. And some part of the infiltrated water joined to this groundwater. And there will be another rock deep percolation. The groundwater flows towards this deep percolation. If there is fractured rock, if there is rock and it is fractured, then there will be gap. Okay, there will be pores in the fractured rock. So there will be deep percolation. So these are the processes involved: interception, evaporation, transpiration, surface runoff, infiltration, and deep percolation. This interception, what is interception is the part of precipitation which is absorbed by dry leaves and branches of vegetation before reaching the ground surface. Okay, when rainfall starts, okay, during initial time, what will happen initially that the precipitation is absorbed by dry leaves, the branches of vegetation, okay, before reaching the ground surface. That is called interception. Okay. That is very minimum part. Okay, this is the schematic diagram of this hydrologic cycle. The precipitation water, some part is joined to the stream flow to the river, that is called runoff. Some part is goes to this infiltration. Okay, and infiltrated water, some part is joined to this stream, this as runoff later. Okay, that is called interflow below the ground surface, but in the upper layer of the soil that flows. Okay, flows, and the latter means that joined to the stream. And this infiltrated water, some part of water joined to the groundwater table, and some part the base groundwater table also joined to the stream flow as runoff. Okay, after a very long time. And the precipitation, this precipitated water, okay, there will be evaporation from the all water body vegetation from this means evaporation and transpiration from vegetation, evaporation from all water body, from land, from vegetation. So combined evapotranspiration. Okay, so this is the whole schematic diagram of this hydrologic cycle. The process involved another is evaporation. Evaporation, that we know, that is the escape of water molecules from the water surface as vapor or gas to the Earth's atmosphere due to high temperature. When the temperature increases, okay, when temperature increases, the cohesive force decreases between the water molecules, and the kinetic energy decreases. Kinetic energy increases. So water molecules which is in the surface. Okay, if you see, this is the surface tension. Well, you know the surface tension. Let a molecule here or here, okay, and another molecule at the surface. Okay, due to the intermolecular cohesion, okay, there will be forces all around the molecule. So it will be in equilibrium condition. This molecule also will be in equilibrium condition. But this molecule, which is at surface, only half portion, the lower half, is attracted. Okay, due to molecular cohesive force. For the upper part, there is no force. So only lower half there will be intermolecular cohesion, intermolecular attraction. So this molecule will be in unstable condition. So there will be tension force at the surface due to this unstable, due to this unequilibrium condition of this molecule. Okay. That tension at the surface is called surface tension. So these molecules which are at the surface, the molecules which are surface, okay, that tends to rise above once the kinetic energy increases. So they try to escape from this water surface. That escape of water molecules from the water surface as vapor or gas to the Earth atmosphere. Okay, that is called evaporation. Okay. Transpiration, there is a loss of water from the free surface of plant cells. Free surface of plant cells, that loss of water, that is due to sunlight, and for its you can say photosynthesis process, the water is used. Okay, that water is lost from this vegetation is called transpiration. Surface runoff, precipitation water which flows on the surface to join the stream. Okay. Infiltration, absorbance of water by porous soil below ground surface due to gravity and capillarity. Okay, due to gravity, okay, some water flows into the ground, and due to capillarity, some water is also absorbed by the soil. So total absorbance water is called infiltration. Also, you can say that infiltrated water is two types. One is that absorbance by the soil, and some part is joined to the water table. Yes, there will be part of the water joined to the stream, okay, later, and some part of the water joined to the water table, okay. And another is deep percolation. Deep percolation means infiltrated water moves towards the hydrologic layer and join groundwater table due to gravity. Okay, due to the fractured rock below the groundwater level. Okay, due to fractured rock, there will be gaps, and that gaps is filled by this water. That water is called deep percolation. That process is called deep percolation. So all about this, all the processes are involved in the hydrologic cycle. Next is the abstraction. So what are the losses from this precipitation occur? Loss of precipitation in the formation from interception, okay, evaporation, transpiration, infiltration. The part of precipitation is absorbed by dry leaves of vegetation before reaching the ground. Okay, it is usually 10 to 15% of the total precipitation. It is assumed. There is no equation, there is no empirical equation, there is no theory involved in this interception. Okay, it is just 10 to 15% is considered. Okay. Next is evaporation. Evaporation that I discussed, that escape of water molecules from the water surface is vapor or gas to the atmosphere. When kinetic energy overcomes the cohesive force between the water molecules due to transfer of heat energy. When heat energy is supplied here in the liquid, okay, we supply the heat energy, then this cohesive force between the water molecules decreases and the kinetic energy increases. So when kinetic energy increases, there will be random motion of molecules. So the molecules will try to escape from the water surface from here. Okay. This is called evaporation. And the vapor pressure is the pressure created by vapors above the water surface. Above the water pressure surface, the pressure created by vapors. There will be vapors, means rise of this water molecules in form of gas. That is called vapors. The pressure which is created by vapors above this is called water surface. Above the water surface is called vapor pressure. Condensation is the opposite of the evaporation. You can say the conversion of the physical state of vapor or gas into liquid state when cooling or humidity air occur. Okay. We can give another example of this condensation and this how precipitation and condensation, how evaporation occur. So, for an example, if you boil water, okay, if you supply heat, there will be the water vapor will rise. That is called evaporation. After some time, if you stop heating and you cover that pot, okay, cover that pot, okay, so you will find some water drops inside the lid, inside that cover, you will find water droplets. Okay, after you supply heat, that water drops, okay, inside that cover, it's nothing but it is called condensation. And the falling of that water balls, if you take it out and then you'll find the water droplets falling, that falling of water drops is nothing but it is called precipitation. The boiling temperature, the temperature when vapor pressure rises to become equal to the atmospheric pressure. Okay, and there will be here evaporation from the liquid, and the opposite process that is called condensation. From solid to liquid, it's melting, and there will be freezing. That is the opposite process. The melting point and the boiling point. Boiling point means above which the temperature when vapor pressure rises to become here, it becomes equal to atmospheric pressure. And after this, when this process, you see this spot and this spot, here the vapor pressure is less than atmospheric pressure. Here vapor pressure is equal to more than equal to atmospheric pressure. When vapor pressure is less than atmospheric pressure, there will be no bubble formation here. But here there will be bubble formation. So you can see a difference between this evaporation and condensation. Evaporation occurs low heat supply, low kinetic energy, strong cohesion. Okay, if you supply heat very slowly below heat supply. There will be strong cohesion, low kinetic energy, low vapor pressure, which will be less than atmospheric pressure. Evaporation may occur without bubble formation. So evaporation may occur, but without any bubble formation. But if you increase the supply of heat, then temperature will be at boiling point. When temperature meets the boiling point, high kinetic energy, weak cohesion, cohesion decreases, vapor pressure increases, it becomes equal to more than equal to atmospheric pressure, and there will be rise and formation of bubbles. Okay, so from low heat supply to high heat supply, when it reaches the above the boiling point, okay, the evaporation, this process is called evaporation. And from the high heat supply to low heat supply, okay, the reverse process is called condensation. So the depends upon the rate of the vapor pressure and the atmospheric pressure, and the temperature depends upon this. The vapor pressure depends upon the temperature, and that boiling temperature, that is called boiling temperature. Temperature below boiling temperature, this condition. Temperature above boiling temperature, this is the condition. When rate of evaporation is equal to rate of condensation, okay. So let's evaporation is occurring, and you start cooling, means you stop heating, okay. Then there will be condensation will start. So at a particular time, there will be evaporation, and the rate of evaporation and rate of condensation will be equal, okay, and that is called equilibrium condition. So a number of molecules leaving from the liquid is equal to number of molecules joining to the liquid. As I told, if you let there is bubble formation, evaporation is occurring, you stop supplying heat, okay, stop supplying heat and cover with a lid, with a cover, okay. After some time, you will find what drops here. These water drops, formation of water drops here is called condensation. Means you stop supplying heat. Means this process starts. Okay. That is called condensation. And falling of that water drops is called precipitation. That happens in the sky, in the clouds. When clouds formation means there will be the water molecules join together. So there will be cloud formation. But this is about evaporation and condensation. Next is evapotranspiration. Evapotranspiration is evaporation and transpiration from solid soil beneath the vegetation. That is called evaporation. Actually, this evapotranspiration means for only vegetation. Evaporation only for the land. Okay. Since in vegetation, evaporation and transpiration both occur simultaneously, so it is called evapotranspiration. Evaporation from soil beneath the vegetation. Transpiration means loss of water from free surface of plant cells. Okay, this is the vegetation. Okay, so this is the soil. These are the soil. There will be evaporation from here. That is called evaporation, and transpiration from the plant leaves. Okay, from plant leaves. So both occur combinedly. Okay, that's why it's called evapotranspiration. To simplify the process, to simplify the theory, okay, it's combined. That's called evapotranspiration. Transpiration means physiological process in which water evaporates from the surface of plant cells. And these are the factors which affect transpiration: atmospheric vapor pressure, temperature, wind, light intensity, anatomy of plants. Okay, so I'm not going into deep about this transpiration. Briefly, we have to discuss because it's not as far as your syllabus is concerned. So next is runoff. Draining of precipitation from a catchment area through a surface channel is called runoff. Runoff consists of surface runoff and interflow. Like I told, this interflow or thorough flow. Okay, it is the flow occur below the circumference surface, but in the upper layer of the ground surface, upper layer of the soil. So there will be, because that water is joined to this stream. Okay, that's called surface runoff, the flow which travels all the time over the surface and through the channel as open channel flow and reaches the catchment outlet. This is the overland flow, is called surface runoff. Interflow means a part of integrated water moves laterally through upper crust of the soil, return to the surface at some location out from the point of entry into the soil. Okay, means here there is entry here there is entry, and they may join to the return to the surface. They join to the surface here sometime some location. Okay, out from the point of entry. Okay, here the water is entering. Here there is join to the water body. So that's called interflow. This interflow is two types: prompt interflow and delayed interflow. The interflow which joins the stream in a short period of time is prompt interflow, and the interflow which takes long time, years after years, to join the stream is called delayed interflow. Classification of runoff based on the time delay. So this prompt interflow means suddenly, means after the rainfall that in short period of time join to the surface. But delayed interflow, it may join to the water table, and that water table water may join to the stream. Okay, it takes long time, years time to join to the stream, years or months time. Next is classification of this runoff based on the time delay between the precipitation and the runoff. There will be direct runoff and the base runoff. Runoff means the water which join to the stream. Surface runoff means the flow which the water which is flowing on the surface or over land. Runoff means that water will join to the stream at last. So the direct runoff means the surface runoff, prompt interflow is the interflow which joins immediately after rainfall, and rainfall on the surface of the stream. On the water body there will be rainfall, but that rainfall is also included in the direct runoff. Next is by base flow. The delayed runoff that reaches the stream essentially as a groundwater is called base flow. It leads to perennial rivers. The base flow is nothing but it's called delayed interflow. The interflow which takes long time, years time, or months time to join to the water table, join to the surface, Means all water cannot join to the surface. Some part of water join to the water table. Okay, so that is called base flow. And due to the base flow, a river can be perennial or intermittent or ephemeral based on this base flow contribution. Okay, so again I'm just covering here. This runoff consists of surface runoff, interflow. Interflow is two types. This interflow is two types: one prompt and another is delayed. Prompt interflow and delayed interflow. EI, DI. So the surface runoff and the PI, and if there is a rainfall on the water body, all is called direct runoff. Okay, and this DI, delayed interflow, is called base flow. Okay. Prompt interflow, delayed interflow. So direct runoff is surface runoff, prompt interflow, rainfall on the surface of the stream. Base flow is nothing but the delayed interflow. So based on the flow, base flow contribution, there will be perennial stream, intermittent stream, ephemeral stream. There is a base flow contribution in perennial river. Okay, throughout the year there will be base flow contribution. Here you can see some base flow during June, during April, May, even during non-monsoon season. Some base flow, some minimum flow is found in the river. That is called perennial stream. Intermittent stream means there will be some contribution during rainfall season. Okay. Limited contribution. When rainfall occurs, there will be some contribution. Okay. Means when rainfall occurs, means during that month, during that time, some period of the time, there will be contribution. but not all over the year. Ephemeral stream, there is no contribution. There will be zero contribution of base flow. These peaks are only due to rainfall. Only when rainfall there will be some water in the river. Otherwise, there will not get any water in the river. That is called ephemeral stream. So based on the direct flow between the stream and the groundwater table, stream can be divided into influent and effluent. Influent stream means if the water flows towards the groundwater table, means here. This is called influent stream. Here water flows towards the groundwater table. Okay, if it is away from groundwater table, means here, away from groundwater table towards the stream, that is called effluent. So remember, towards the stream, influent, away from groundwater table, that is called effluent. Okay, usually perennial rivers are effluent streams. Perennial rivers means there will be base flow, groundwater flow to the stream. This is the catchment area, drainage area, watershed area. The area of land which contribute water to a stream in precipitation occur. The catchment area can be whole river or a tributary river. So we should understand this catchment area basin. Basin means the catchment area of whole river is the basin. Okay. This is the catchment. This is the of this stream. This is the catchment of this stream. Okay. And this is the catchment of this stream. Another example. This is the catchment of this stream, and this is the catchment of this stream. Okay. So this is when rainfall occur here. Okay, here. Then the water will join to this stream. When rainfall occur here, the water will join to this stream. Okay, so due to the elevation difference, the water is when rainfall occur in this area, the water will flow towards this stream. Okay, when rainfall occur here, the water will join to this stream. So this is the catchment of this stream, and this is the catchment of this stream. Okay, catchment area, and this divide line. Okay, which divides the two catchment. This is called ridge line. This is called ridge line. The ridge line means line which divides two catchment or watershed basin. So these are the small streams, so we can say it is catchment, but we cannot say basin. For the whole river, this is the whole river from origin, from start to the end. Okay, from whole river, that catchment, the whole catchment of the whole river is called basin. Here there is another stream here, another stream. Then might be, so there will be another catchment here. There will be another catchment. So when rainfall occur here in this region, the water will join to this stream. Okay. When rainfall in this region, the water will flow to this stream. Okay. So this line is called ridge line. This is watershed hydrologic project. We know there is already might have heard of this term. That is hydrologic project. Hydrologic project means it's a conservation of mass. How much water means volume of water is coming and how much water is going. Means here precipitation is coming. Okay. ET, there will be loss evapotranspiration, and here there will be some part of water joined to this groundwater. Okay, and some part is stored in the groundwater as groundwater, and here there will be overland flow, that is called runoff in the stream, and some part of the groundwater joined to the stream later. So total, if you use the conservation of mass, conservation of volume, then this precipitation plus groundwater inflow minus this discharge overland flow Q plus ET plus groundwater. Okay. The flow which is coming out of the groundwater table. Okay. So change in storage. Okay. With respect to this groundwater storage, we can write then change in groundwater storage per unit time will be P plus G in minus Q minus ET minus G out. So at steady state, means the storage change in storage per unit time is constant. Delta A del S by del T is 0. So P plus Gn will be equal to Q plus ET plus Gn. G out. Okay. So this is the conservation of mass or conservation of volume. For hydrologic production, there is the P precipitation and groundwater inflow. The runoff hydrologic circulation is Q plus this G out plus this ET. So this equation is written in considering this groundwater storage. Okay. So this is the hydrologic budget as far as this groundwater is concerned. So this was, thank you so much.